Good morning. We will continue our discussion about cyclotron. In the last session also we have done some problems based on cyclotron. In this class also we will continue the same thing. Now take down this. State the principle of working of a cyclotron. State the principle of working of a cyclotron. Show that the cyclotron frequency is independent of the velocity of the charged particles. State the principle of working of a cyclotron. Show that the cyclotron frequency is independent of the velocity of charged particles. The principle, the principle of working of a cyclotron. It's a machine which works in the presence of both magnetic field and the electric field. And we know that the magnetic field will make the particle to follow a circular path or a semicircular path, and the electric field accelerates the charged particle. First we'll write the principle. In cyclotron, both electric field E and magnetic field are applied normally. In cyclotron, both electric field E and magnetic field B are applied normally to velocity V. To velocity V of the charged particle. Such that the electric field accelerates the charged particle and magnetic field makes the charged particle to move in circular paths. Repeatedly so that charged particle is accelerated to large velocities and hence large kinetic energies. Under the combined effect of electric and magnetic field. Okay, so let me read out once. In cyclotron, both electric field E, you can mark these fields as vector also because they are vector quantities. In cyclotron, both electric field E and magnetic field B are applied normally to velocity v of the charged particle, such that the electric field accelerates the charged particle and magnetic field makes the charged particle to move in circular paths repeatedly, so that charged particle is accelerated to large velocities and hence large kinetic energy under the combined effect of electric and magnetic fields. So in short, I can say that in a cyclotron the electric field is used to accelerate the charged particle and magnetic field B is used to make the particle to move in a circular path or semicircular path. Next question is, show that the cyclotron frequency is independent of the velocity of the charged particle. There is no dependency of frequency with the velocity. Now we know when the charged particle in a magnetic field moves in a circular path, the radius of charged particle is given by radius of charged particle as, I can say it as r equal to the radius of charged particle is r as mv by qb. M is the, remember, or you can write also, mass of the particle, v is the velocity of the particle, q is the charge, and b is the magnetic field intensity. Now frequency is 1 by t, so let us take the time period of charged particle. Since it follows a circular motion, the time period will be equal to the circumference of the path divided by velocity. So this we can write it as 2 pi r divided by velocity v. Now substitute for r. What do we get? T is equal to 2 pi by v into the velocity is mv by qb. Now you cancel out the common terms. Velocity and velocity will get cancelled, and hence t is equal to 2 pi m divided by qb. Frequency f is 1 by t. Frequency, because we have to show that the frequency of the cyclotron is independent of the velocity. Now frequency f is equal to 1 divided by t. F is equal to 1 divided by t. Now which will be equal to 1 divided by t is 2 pi m divided by qb. Therefore f is equal to, frequency f is equal to qb divided by 2 pi m. qdp divided by 2 pi m. Now if you see this expression, f depends upon q, b and m, but not on velocity. From the above formula, it is clear that frequency of the particle does not depend on the velocity of charged particle. Charged particle does not depend on the velocity of charged particle. Hence the proof. Okay, so from this it is very clear that the frequency does not depend upon the velocity. So whatever it gains the velocity, the frequency will remain the same. And I hope you understood this derivation. Like it's a very small proof,